All right, now in this video, I want to kind of go over a few types of more like AP style substitution problems, and they also let us use use substitution sort of symbolically. So you'll notice that some of these functions just say like f or f prime or g prime. So let's just kind of do a few of these to see what these look like. So for example, this multiple choice asks us to evaluate this indefinite integral here, f prime of 2x over f of 2x. And so one thing I note is that, you see a function and some version of its derivative, right? So I see f and an f prime. So that usually means we should let u be, in this case, f, so that when I say when I take its derivative, I have du equals f prime of 2x, and then times a 2 by the chain rule with a du. So now this denominator can be replaced with a u, and then the numerator here, f prime of 2x dx, f prime of 2x, sorry, this is supposed to be a dx here, fix that. F prime of 2x dx almost is exactly what I want. If I just divide both sides of this by a 2, and now that 2's gone. So du over 2 will go there. So now I can translate my integral to be, so f prime of 2x dx is now just, I'm going to put a 1/2 there. It's 1/2 du. And then my denominator is just u. Now I just need to know the antiderivative of 1 over u, which is the natural log of the absolute value of u plus c. And we substitute back what we actually had in place for u. And then I recognize my answer up there as d. All right, let's try a couple more. So in this example, it's something similar. They gave us these values here. That probably means we're going to need them, so I'll just note that. But here's my integral. It's a definite integral, right? It's a definite integral that's because the limits of integration are there. So I see a function f and I see its derivative. So that immediately tells me I should let u be the function so that du becomes its derivative. And I look back up, I see this can be replaced now with my u, and this f prime of x dx is now just du. So it's a nice clean substitution there. So my definite integral will become e to the u, and then f prime of x dx just gets replaced with a du. Now let's update the limits of integration. So remember, this initial problem is in terms of x, right? As x goes from 0 to x equals 2. Now when, I'll write this out concretely, when x equals 0, if you look at the relationship above here, u equals f of 0, but they conveniently told us what f of 0 is. F of 0 is 1. Right, so now I know that I should replace the 0 with a 1 here. And when x is equal to 2, u is equal to f of 2, and what do you know? They told us that f of 2 is a 6. And so now I can evaluate this integral as though it was always in terms of u. So the antiderivative of e to the u is e to the u, evaluated from 1 to 6. So I get e to the 6th minus e to the 1, and I recognize that answer as b. All right, and we'll finish with this one. This one isn't a multiple choice, but it kind of indicates an interesting substitution. So I see a g of x, and I see a g prime. So you might think, let's let u be g of x, because then du will be g prime. The problem is you still have this sine and cosine business. So I think we're going to let u be something even bigger, because the derivative of sine happens to be cosine. So if I let u be this whole thing, I think its derivative, the du, will become this with the dx. So let's just give it a shot. And I should note that, you know, there's nothing wrong with a little guessing and checking. This is a harder process than taking derivatives. So if I let u be sine of g of x, then du would be, so the derivative of sine is cosine. So it's cosine of g of x. By the chain rule, I got to follow it up with a g prime of x dx. And so you'll notice then that u can replace this, so that'll become a u squared, and du replaces perfectly everything else, right? Everything else is what I have here equal to du. So this becomes a nice, clean antiderivative once I've made the substitution. Sine of g of x squared, so that just always becomes u squared du. And the antiderivative of u squared is 1/3 u cubed plus c. And putting back our u for what it really was makes it 1/3 sine of g of x cubed plus c. All right, so I just wanted to do a few problems like, you know, the kind of like AP style problems, I would say. They're a little more symbolic, and they're not so concrete, but they're good ones to go over.